Hi. Hi, everyone. Thank you all for coming. I'm Sebastian from Nocturne. We're building what we call a usable privacy protocol on top of Ethereum. Now, this talk is going to be about what useful privacy is and about how do we get it. So some things that we want from a useful privacy protocol is first around payments. When I send money to someone else, I want to make sure that, I want to make sure that as a sender, I can remain anonymous from the protocol. And I also want to make sure that if I'm receiving money, I can remain anonymous. And in this interaction between a sender and a recipient, the recipient does not need to share any private or special information out of band with the sender. So if we want a user experience that's something almost like Venmo, where if I know someone's contact information, I can just send them a payment without needing to have any special information from them. We also want a unified anonymity set because we know that the bigger anonymity set, the better it is. And then in addition to that, we would like to have direct compatibility with existing on-chain applications. And because part of usable means, well, useful, right? And so if I'm going to interact with some private protocol, I'd like to be able to do things I want to do with it, whether that means staking into Lido, whether that means using assets that I have on the layer I'm currently on. We also would like to, when possible, be able to support fully confidential payments within the pool. So if I don't need to reveal the asset and the value, I shouldn't have to. And then finally, some more practical concerns that have nothing to do with the protocol itself is that the scheme that we use should support the ability to scan all of the information the user needs off of the blockchain itself. The user should not need to manually copy and store notes, as we call them, like some protocols do require. And finally, the protocol should be relatively free from what we might call foot guns that make it really easy for the users to dox themselves by using the protocol. And so what we'll do is look at two recent solutions that Nocturne happens to combine, and then we'll see kind of what we get from what. So as a review, so a shielded pool is the general design principle of pretty much every privacy protocol that's deployed in practice today. That includes things like Zcash and Aztec. And the general principle is, in case you're not familiar, there's a pool. And when you deposit into the pool, you create a UTXO, and that UTXO gets submitted into a Merkle tree. Then later, when you want to spend that money, you use a ZKP to prove you owned the money, and that you created some value called a nullifier that prevents a double spend. Once you then submit that proof to the contract, and if the proof is valid, the contract will let you do what you want with your money. And there's several variants of this, but at a base level, it has certain properties that we like. So one of which is that if there's someone outside of the pool that I want to send money to, I can send money to them, right? And I'm not revealing my identity in doing so, right? But if I want to receive money from inside the pool, usually in order to do that, I need to share some kind of information out of band to do that, because we won't get into the details, but in order to basically create this note that anonymously binds to a certain spender, a sender would have to receive some kind of external information. We do get in a unified anonymity set, of course, because that's kind of the whole thing. We do not get, but we don't necessarily get direct compatibility with on-chain applications, because every time you want to perform some kind of operation, you need to provide one of these zero-knowledge proofs and unwrap and rewrap funds as you go. And this usually requires building maybe like an adapter contract or something similar along those lines, which kind of limits the compatibility with what a user might want to do with their assets. It also is relatively straightforward to make the asset and value confidential when you're transferring assets within the pool. But most of these designs on their own don't necessarily have the property that you can just scan everything you need off of the blockchain. In practice, you have something either called like, the note either has the nullifier itself, which are supposed to be secret, or it has something called like a nullifying key in the note, which has to be secret, or it has some other kind of secret information in the note that cannot be revealed publicly on-chain and cannot be kind of derived from public information on-chain. But at the same time, because the protocol is like relatively simple, you can withdraw your funds and spend them. It's relatively straightforward to not dox yourself as long as you follow some certain guidelines. So a recent thing that came out that kind of tried to like address the recipient the recipient privacy problem, and that's called stealth addresses. So EIP 5564 presents this protocol by which a sender can effectively generate some shared secret using some variant of like a Diffie-Hellman exchange that allows a known recipient to be able to derive a key that corresponds to some EOA, but without revealing who that recipient is. And so this picture is from Vitalik's blog article. But the general gist is that this public, secret, this public value allows only the recipient to derive the shared secret to be able to derive a key corresponding to an EOA. And so what the sender can do is send this value to the recipient, and they can actually just publish this on chain. It doesn't reveal anything in and of itself. And then they can send any assets they want to send to the receiver straight into this EOA. And then the receiver can derive the keys for this EOA, and now they just have an EOA with some assets that were sent by the sender. This is actually really cool because it gets around the need to explicitly interact with the recipient when you are sending funds. And it gets around, and it actually solves some other UX problems that are adjacent to that. But one of the drawbacks of this is that now all of a sudden is that because this is only working with EOAs, right? Like the sender is doxed, right? You're going to see a Ethereum transaction somewhere in the blockchain saying that an Ethereum address, the sender, moved money into some EOA, which you don't know who the owner is. But you do get recipient anonymity without out-of-band interaction, which is really good. The rest of the drawbacks mostly have to do with the fact that now everything is just kind of like these ephemeral, EOAs, right? So there are issues, for instance, that we don't have a unified anonymity set. So if someone generates some number of EOAs targeted to a certain, say, a certain recipient, right? You might not know who that recipient is, but you know that there's only a certain number of EOAs that have ever sent funds or received funds from the EOAs. So the anonymity set is not necessarily unified across all users of the stealth address protocol. It also has direct compatibility, but the other benefit it does have is because they're EOAs, well, you could just use whatever DeFi protocol you want. You can throw them into Lido. You can throw assets into a lending protocol. You can swap them on Uniswap. You can do everything that you do right now, and you can get some degree of cover. But the main problem with stealth addresses, as they are today, is that the protocol itself is hard to use without inadvertently doxing yourself. And this is actually a big enough problem that I have an entire slide just to talk about it. Basically, the problem is that once you send funds to a stealth address, right? If I'm paying someone USDC via a stealth address, they don't have any gas in their stealth address. So if they want to be able to move that USDC, well, they need to get gas from somewhere, right? And so, okay, well, I have some gas in my other EOA. Let me just send it there. Oh no, I've doxed myself, right? Another way that this could go wrong is even if I do, have gas, maybe I ask the sender to top me up, right? Now I have assets spread across multiple different stealth addresses, and maybe I have some positions open on various DeFi protocols, and I want to move money into some positions versus other positions, and in doing so, there's actually a lot of non-straightforward ways that just depositing into the same pool and ending trying to get like the same position, or maybe depositing into, say, Lido with both of them, but then withdrawing all the funds to another of them, then I've linked the two stealth addresses. And so these things are very, very non-straightforward. It's very easy for the user to shoot themselves in the face with a stealth address on its own. And so app devs must kind of like add something to it to make them fully idiot-proof. And that's really what Nocturne is. And so Nocturne takes the idea of like a stealth address, and it combines it with a shielded pool, where instead of using EOA stealth addresses, we use a stealth address scheme that's sort of baked into the protocol. And what this actually gets us is pretty much everything that we want, in addition to some other neat properties that I'll talk about in a minute, right? So it gives us sender anonymity because it's a shielded pool. It gives us recipient anonymity without out-of-band information because the sender can generate a stealth address for the receiver without needing any additional information from the receiver. It has a unified anonymity set because it's a shielded pool. It has direct compatibility with existing on-chain applications because of something we've added to Nocturne around a built-in gas compensation mechanism. And so what that actually means is that when you submit a transaction to Nocturne, you basically can set aside some funds for gas compensation for the relayer that's processing your transaction, and that basically allows it to actually work with existing applications without any adapters. So using Nocturne, you can deposit funds into Nocturne, and then you can spend them immediately by going into a Lido pool or swapping them for a different asset, and because there's stealth addresses, you can actually, the protocol can actually can process refunds because the entire contents of a UTXO do not reveal anything identifying about the user. It's just the stealth address. So, and everything else you kind of get from a shielded pool. And then the other benefit here is just like a stealth address, the user doesn't have to track their UTXOs or nonces. So everything you need, you can scan from the chain itself. And then most crucially, this avoids the sort of foot guns of stealth addresses because all of this can now be kind of like rolled up into the protocol where you just kind of, whenever you do a transaction, you just sample a random number and use that to generate your stealth address. And this is all like rolled up under the hood, and these stealth addresses are no longer stateful, right? So it doesn't really matter what stealth address I'm using for what transaction. As long as I have a UTXO in the pool, and I can generate more stealth addresses, I can spend my money, and it's all coming out of the same anonymity set, and so I don't really have any of the you don't really have any of the foot guns that we have with stealth addresses. The one other thing that's cool about Nocturne is that we actually get sender and recipient anonymity between the pool and the outside world. So what that means is that if there's a sender, say for instance, a DAO that has a Gnosis safe, right, and I'm an employee that I am in Nocturne, what we can actually do is the DAO contract, being a totally public contract, can send money to a designated stealth address in Nocturne, and then as a recipient, I can remain anonymous. And so this is something that can be built now that we have sender and recipient anonymity at the same time. Yeah, I mean that's it. I don't know if there's any other questions. We can move to questions. Yeah, hey.
Are you guys using fuzzy message detection, or how are you handling the recipient scanning problem?
So the question was, are we using fuzzy message detection or doing any, or if not, what are we doing to handle the note sync, UTXO sync problem? So currently, we just do a linear scan. There's a lot of things you can do on the engineering side to make this pretty snappy. But of course, in the future, we do plan on doing all this kind of stuff, right? Fuzzy message detection is an option. There are actually some other techniques that you can do for subsets of the problem. For instance, a big chunk of the linear sync, more than half of it, is actually just replicating the on-chain Merkle tree in the client. And that can actually be accomplished entirely with PIR, and you can eliminate the sync entirely using private information retrieval for that, because all of the new leaves that are inserted into the tree are public. Yeah.
Out-of-band interaction isn't always the worst thing in the world.
It isn't, but I think it's an important UX feature that you might expect, especially when it involves private information, things that you would not want to reveal outside the world, and it kind of does require you to build some kind of solution around it. And so, like, if we have a privacy protocol that's like linked to some secure messaging protocol that's like baked into Ethereum keys somehow, that would be a cool thing to build, and that would solve a lot of problems. But we don't have something like that right now. Yeah. Sorry. Yes. White shirt at the top. Sorry, can you say that again?
Is there a way to switch between anonymity and your real identity in the future?
In what exactly do you mean by switch?
Like you are making a transaction, anonymously, and for a certain time frame, maybe you want to reveal that transaction or reveal your identity to a certain party or to the public.
Oh, I see. Yeah, so the question was, if I want to remain anonymous, is there a way that I can later not be anonymous? So if I want to selectively reveal my identity to a certain party or to the public, yeah, I mean, you could totally do this. You have all your private state locally, and if it's maybe to a particular party, you could prove arbitrary statements out of it, and we could build whatever ZK circuits that need to be built to do so, or if you want to reveal it to the public, you can always just do so as well. Yeah, and it's all committed in the Merkle tree, so you can prove that it's legit. Next question? Yes. The blue shirt, yes.
Are you using ZK technology in VMOL? And if so,
Yes, we are. Yeah. Now, we're using Groth 16 Circom. It turns out that like these circuits are still not all that complicated. The tooling is there. It works. It works on Ethereum today, and it allows us to spend time on the things that matter. Yeah. Any other questions? No.
Can you elaborate a little more on the existing on-chain DeFi integration?
Yeah. So the main problem that a lot of shielded pool designs have today when it comes to interacting directly with existing applications on-chain is, so there's problems on I am sending out of the pool to an external application, or I'm more generally interacting with an external application from within the pool. And then there's the category of problems that arise when I have an existing application that wants to send money into the pool. In most cases, there's two things that kind of come from this. So one is like if I'm a contract trying to send deposit into the pool to a specific recipient, right? What I need to do is I need to direct that deposit to a recipient, which means that in designs where the note itself cannot be 100% entirely revealed on chain, you can't do this because that calling contract needs to have that in order to like create some kind of commitment to it and feed it into the pool. In our case, because the owner field of the UTXO is a stealth address, the user can generate this offline, and then and this can just be fed all the way through say a Gnosis safe, where you say we're going to pay this set of employees and we're going to fire them all off at once. But all these employees are anonymized, but through a stealth address. Yes, hello?
Can you easily sort of exploit your transaction history in this type of system?
Yeah, so you have, so whenever you perform an operation, you have events on chain. And so, this is more or less an indexing problem on the client. So the client can pull everything it's ever done, and it can parse through its stealth addresses to see which ones were its stealth addresses, and it can recover everything if it needs to. Yeah.